So we will start with the SQL presentation. I'll be presenting the slides from 33 to 35. My name is Jigeesha Jain, and the contents of the slide are: what is tuple, creation of tables, insertion of tuples, basic structure, and relational algebra correspondence. The topics that are covered within the slides 33 to 35 are insertion, basic structure, and relational algebra correspondence. But to understand those concepts, we must first know what is tuple and how are the tables created. So moving on, a tuple is nothing but a single row which contains information which is related to that particular data. A table contains multiple rows and columns, out of which rows stand for tuple and the columns that are there are attributes. So basically, in a relational database, a single row is contained and that is nothing but a tuple, or we may also refer to it as a record. Now that we know what a tuple is, let's move on to the next topic, that is creation of tables. Now, table is nothing but multiple tuples combined together. The syntax of creating a table is create table and table name, column 1 data type, column 2 data type, and then we may keep on adding those. I have executed a query here which shows a real-time example. Here I've created a table for employees which contains multiple columns. These columns are nothing but attributes. So employee ID, which acts as a primary key, then first name, last name, age, and department. And after executing this query, as the syntax is correct, the table gets created. We will be using this example for further slides as well. Now we will start inserting the tuples once our table is created. The syntax of inserting tuple is insert into table name, attribute list, values, and the value list. So as you can see in the example below, here we use the insert into employees. Employees is the table name. And then we have the attribute list. We have here I have inserted the employee ID the way we have mentioned before, and then the first name, last name, age, and the department of that particular employee. And this way I have created multiple rows by adding and inserting values into the employee table. So in this way the tuples get inserted into the tables. Next, I've used select star from employees, which select star means everything, what all tuples are present inside that particular table, all of them will be selected and it will display all those one by one sequentially. So here we had initially created 3 rows and all those 3 will be seen here. There are multiple columns, that is employee ID, first name, last name, age, and department. So once this structure is created, once the table is created, we can find the basic structure here. As you can see in the photo below, it contains 3 clauses. One is select, next is for, and third is where. What it does is it selects something whatever we mentioned, we may mention 2 to 3 different attributes, and it will select those from that particular table uh, only when a particular condition is met. So it will give us all those results when of those particular tuples where that particular condition is met. So in order to make things more clear, let's take an example of the same table. Here we want to display the employee ID, first name, last name, and department from the employees table, which is created already. Where is the condition? After where we have the particular condition which has age which is less than 26. So what happens is it will return, or it will display all those names, employee ID, first name, last name, department from that particular employee table wherever the age is greater than, wherever the age is less than 26. So then we have here Jack Smith and John Green, because in the table initially we had only these two whose age is less than 26. Moving on, in order to make things more clear, I have taken multiple examples. I have selected first employee ID, first name, last name, and age from the employees table, where I have changed the condition here where department is sales. So whenever we want to apply various filters, when we have huge database, so in that case we can apply various conditions and then we get the result automatically. In the second image, I have given a new condition. I want just the first name from the employees table where the age is equal to 27. So it will display all the first names of all the employees whose age is exactly 27. Last but not the least topic is what is the correspondence with the relational algebra. So SQL is a non-procedural language, whereas relational algebra is a procedural query language, now which takes relations as the input as well as generates a relation as the output. It basically uses operators in order to perform the queries. So I have tried to make a correlation between the SQL and relational algebra. Whatever we have, whatever till now we have seen, that there's a select clause, there's a from clause, there is a where clause in the basic structure of SQL query. In the same way, in the relational algebra, we have projection, which is similar to select. We have Cartesian product, which is similar to from clause, and we have selection. As the name itself suggests, we will have it in correspondence of where clause. So in relational algebra, the query can be written as pi, which is nothing but the projection, even A2, A3 up to AN. These are different attributes. And then we have the selection wherein we put the condition, and from we have the Cartesian product. So in the example below, we have taken the same example, the same table, pi, employee ID, department. These are the two attributes. And then we have sigma, and we have the condition whose age is greater than 23. And it will get these details from the employees table. So in this way, we can get the relational algebra correspondence with our SQL. that's it. That's all from my side.